All right, good morning, everybody. Who's ready to talk about MCP? So just to make sure you're the right breakout, this is breakout 197, Building Enterprise-Ready Security Agents with MCP Servers. Thanks for making time on a Friday with us. We're obviously very excited to be speaking with you all. So my name is Kyle Champlin. I'm a product manager here at Google with the SecOps team. I'll be doing this kind of the opening part of this session. But with me today are two very special guests who will be coming up subsequently. So Dan, who's a cloud security AI engineer. He's been really deep into all things MCP, really from the beginning of when we've been kind of putting out stuff into the ether for this. And also a very special guest, Hakeem, who's going to come up. He's a director of SecOps at Salesforce. And he'll be walking through a real-world example of leveraging agents and MCP to power those agents to do real work on behalf of security teams. And last but not certainly least, I want to call out my friend and colleague Mike Hakeem, who couldn't be here today, so I'm actually filling in for him. You can consider me an understudy. So he's really crafted a lot of the strategy and thinking of what we're going to do with agents, with MCP, within SecOps more broadly. So in terms of what we're going to cover today, I'll, like I said, talk a little bit about sort of the 101 pieces of this. If you're already an expert in all things MCP and AI and agents, that's cool. I think you'll still learn a little bit from me, but we also wanted to make sure that folks that are sort of dipping their toes into the water here have a good mental model for how this fits into the overall stack. From there, I'll turn it over to Dan, and he's going to take you through a little bit more technical depth and detail, and talk about really how you can roll your own and move it all the way through to like a fully managed capability. And last and most excitingly for me, and I've seen the talk a couple times now, is I get to watch Hakeem really walk us through the real world experience of building out an agentic SOC, and really a lot of the key considerations, like the learnings of that journey, and he's going to share that with y'all. So think of it as sort of, I'm the theory part, Dan is the practice part, and then production is going to be Hakeem to take you through that. So that said, a little over a year ago, there's a tweet from a guy named Sundar, maybe you've heard of him, alluding to a line written by the great bard Shakespeare, to MCP or not to MCP, that's the question, let me know in the comments. And I just say very simply, and maybe it's stating the obvious, of course, but yeah, it is to MCP. I think this has emerged as the de facto protocol for which we're going to sort of assemble and compose agentic workflows, not just in the SOC, but just more broadly. And you've seen a lot of that probably throughout Next this week. So why would we do this? So just to define it again for the folks that may not be familiar, MCP, or Model Context Protocol, is a protocol that standardizes how AI and AI agents more specifically interact with each other, and they interact with this sort of outside world vis-a-vis APIs most typically. You'll hear terms like resources, tools, and skills. Dan will talk a lot more about that as well. And like most protocols, the idea is really to support interoperability, right? So it's not just interoperability between agents themselves, but even between models. So if you're going to compose a set of workflows and you need to bring different things to bear, maybe you're using Gemma for part of it and Gemini 3.1 for another part, MCP helps abstract those things away. And so to illustrate this a bit more and to stay kind of within the milieu of security tooling, point-to-point interactions. Who has actually used an AI agent, Gemini probably, to go talk to SecOps by raise of hands, show of hands? And so early days, even when there was kind of the early days of MCP, you'd have a config file, you'd have a prompt that you're kind of constantly tuning to get the right output repeatability from an AI agent, or even just from a chatbot. And so that can be a little onerous and time consuming. And the other thing is you don't get to share all the work you do trying to fine tune how to interact and how to build these things in a durable fashion. And so MCP helps support that, and it provides that layer of abstraction to manage those capabilities. As I'll show you in a little bit, we also have a way to deliver this where we provide authentication and authorization and all of that. So all those pieces are built into this sort of overall protocol, but there's also a bunch of supporting capabilities that Dan and Hakeem will talk about that are just as important to consider. So, like I said, there's some additional benefits just to kind of keep in mind when you're saying, like, why should I use this? Why should I think about even deploying this in Cloud Run or using the managed OneMCP from GCP? Really, the idea is like you want more control and by extension determinism in sort of the workflows you're building out. And Hakeem will talk a lot about determinism and sort of repeatability. There's a lot that goes into that. Scalability and flexibility, so you have to, those are both considerations and benefits. So when you're doing it one-to-one, you're sort of writing prompts or just creating markdown files locally as you're interacting with an agent. That doesn't scale to the larger org. They don't get the benefit of those learnings. And in general, I think you just have to think of if you're going to compose these into complex workflows and tasks, like you need a central place to sort of be a clearinghouse for testing those ideas and getting them refined and durable, like I said, and repeatable. So in May of last year, I guess shortly after Sundar's tweet, our very own Dan started with a number of other folks building out a capability called MCP Security. It's on GitHub. If you do one thing at the end of this talk today, please just check this project out. When I first started at Google, I think right when this came out, was when I joined. And it's fascinating just how this has evolved so incredibly quickly. And this was really sort of providing a self-managed set of MCP servers that you could then interact with GTI, SecOps, and a bunch of the security portfolio, Gus portfolio for Google. And this is really going to be an area we have to continue to invest in. I mean, part of it is it's not always going to be the case that the wholly managed system or service is going to fill every need. And as we add new capabilities, this is largely where you're going to see kind of the cutting edge of those get exposed. And it's also quite easy to use. I'd say for somebody who's fairly technical, it's getting up and running is quite simple. And if you are familiar with sort of other MCP servers, it's going to feel very natural. It also uses ADK under the hood, so it's a good way to dip your toes into that as well. So to give you an overview and hopefully some more context for what Dan and Hakeem will be diving deeper on, let's talk about a typical MCP client-server interaction. The client, in this case, is going to be Gemini. We could say Gemini Enterprise, I guess. And that takes input and intent from the user. So obviously we say prompt or an interaction, some piece of text. And then it will work across multiple products like SecOps, Wiz, Okta via their respective MCP servers. So the idea here is that it's not always the case, but what we've seen it as a pattern is each product will have a server that helps sort of define the tools and the workflows that the agent will then adapt to. And as a simple example, and you've probably seen this before, it would be like, hey, get me the critical alerts from my SIEM, from SecOps. That will then talk to the SecOps MCP server. It will then pass that context to the Google Threat Intel or GTI MCP server to get some additional enrichment, maybe on a file hash or a domain, and then pass that on to Wiz for asset information or misconfiguration, sort of asset and inventory, and then invoke Google IAM if you find that there is something potentially malicious, and then you'll sort of quarantine the user identity, for example. So all of this happens through these servers, and it also, the interface that I talked about earlier, the client, is you speaking to something in natural language. And it is almost like, for me, borderline spooky to see how good these things have gotten at sort of intuiting what your intentions are and doing it at a repeatable scale. And you can do that across not just obviously Google SecOps, but a bevy of products and a bevy of different capabilities. So that said, when we talk about the mental model and a way to think about this, I think these architectures are moving very quickly. We're discovering them in real time, and it's very exciting to be part of this. The way to think about this is when you're obviously executing some agentic workflow, it is consuming compute, often in the form, in our case, of TPU compute. And that underlying infrastructure obviously has to be there to handle all these requests. There's also the kind of what I call AI-specific infrastructure, and this is like how do you pick the models, how do you route the models. It's almost sort of a software layer to help maximize the benefit of that underlying compute infrastructure. And then all the really important stuff, sort of where the humans have to make decisions and design patterns and architectures that are durable and sustainable and secure, all of that, is kind of these three pieces at the top. Dan will get into this, especially with I forget the terminology now. I keep calling it Jeep, but it's Gemini Enterprise Agent Platform. That's going to help you do things like governance, IAM, and logging, all of which you can also do and roll your own. We'll talk about that in a minute. There's also this idea of centralizing intent and reasoning. We talk about RAG and document stores. We talk about memory. And then there's the capability surface itself, and that's largely where MCP is living, but it's underneath those other capabilities. Like how do you put governance on? Who has access to what tools? It's sort of an interesting sort of thought experiment. There are cases where you may want an agent to have more access than the user invoking it, but not to leak information to that user. So you have to think through these problems pretty thoroughly, and Hakeem will show you like a really cool example of how this has come to fruition. That said, there's obviously downsides, and I think it's important to know, like, it's not something to be scared of, but we have to take due care. It's still software. That software is going to have to get patched and updated and managed, and so MCP servers are running somewhere, right? Ideally in Cloud Run, probably. But as we've seen, when we use these AI agents irresponsibly, and these MCP servers have over-provisioned access, or people are maybe not as thoughtful as they could be about where they're storing secrets, how they expose environment variables, or even just looking at the prompts that are being pushed to the MCP server, look, it can open you up to additional risk. Now, this is true of all software for all time. The big difference is we're moving so quickly, I think folks are quick to forget that you have to shore this up. And so if you think about the risks that are amplified by this, by sort of making more tools available to your LLMs, don't shy away from them. And again, don't be scared, but let's be really clear-eyed about the trade-offs here, and that there's always going to be a place for experimentation, safe experimentation, as well as sort of enterprise scale. And that governance piece is incredibly, incredibly important, and I think is doable whether it's through one MCP or managed MCP services, or ones that you roll on your own. And so we'll talk a little bit about what we're trying to do in Google Cloud Security. In fact, if you've been to the Expo Hall, we have a bunch of talks around how to secure things through like Model Armor, for example. And so there's a way to reduce risks and toil for sure. That said, we also recently announced what we call one MCP, and this is managed MCP for Google Cloud, specifically for SecOps. And so the idea here is that it's going to lower the bar to security. This propagates my, pardon me. This propagates my identity as a user of SecOps. So if you're using Cloud IAM or whatever, it knows who I am and what I have access to. So it's still governed by IAM policies. You get the benefits of scalability. So if you've ever sort of tried to stand up an MCP server locally and you want to scale that to thousands of users, you don't have to think about that, obviously, with the wholly managed MCP service. And it also integrates with the broader ecosystem, right? So when we talk about that governance layer, you're not having to invent it from scratch. It's really well plumbed together. And so when you think about sort of agents that need to reason over a lot of tasks, maybe touching data stores and systems that might be slightly sensitive, this just provides you a lot of leverage and reduces the amount of toil you have to deal with. And then also, the client side is another thing we're going to continue to enhance. So inside of SecOps, if you have folks that are not comfortable with that CLI modality, having it just as a normal GUI interface that can still talk to those systems and compose specifically what we'll call first party or Google SecOps, GTI, et cetera, workflows, we'll provide that as well. So I'm going to do a brief demo before I invite Dan onto the stage, just to give you a sense of how to do this with Gemini CLI. So if we can go ahead and switch to the laptop. All right. So I have Gemini CLI already running here. If you haven't checked it out, it's very easy. Go try it. One thing that actually we also recently released is an extension specifically for Google SecOps, the RMCP server. And so I went and installed this. It's just a Git one-liner, right? You just execute it. And you'll see it sets my project settings. It sort of knows how to talk to it. These are configs for the agent or context for the agent to make the right calls to the right endpoint. And if you look at the actual MCP server, you'll see I now have this remote MCP, and it even tells me here in the CLI that what I'm talking to. So this allows me to very easily get up and running. I'm not going to go through authentication specifically, but you can see I can sign in with my Google identity. So all the setup pieces are very simple to do, and they're all controlled by all the investment you've made in governance around IAM, access, roles, et cetera, for SecOps. So we'll use kind of what I think is becoming the canonical example. We'll ask it what tools it has available. And I really hope this works because I've been doing it all morning. There's going to be tool lists that are enumerated by those MCP servers. So all that configuration, like I said, is managed external to the actual local CLI agent itself. And so they're managed, and there we go. So it's spitting out all the tools it has available to it. And I can, for example, ask another canonical question. What are the 3 most recent cases for SOAR? Give me the case IDs, the assignees of the case, and the last modified date. And so all this is like handled for me. I don't have to worry about scaling. There's a ton of auditability and what we'll call observability that Dan will allude to later on. Those are critically important as we look to adopt these things in a durable way, right, when we're doing it in production in particular. So that's my demo. I do want to invite Dan up to get into the nitty-gritty, which I'm sure you're all very interested in. And we can switch back to the slides if that's okay.
Thanks, Kyle. So Kyle showed turnkey MCP client in the product that is fully managed. And alternative is to build your own custom agents, which you can tailor to your environment. In addition to the MCP tools for Google Threat Intelligence and managed MCP tools for Google SecOps, you can also add third-party MCP tools like Wiz, CrowdStrike, Okta, and many others. If your tools don't provide MCP servers, but they do provide an API, you can even roll your own MCP. I've been speaking to these 2 paths to agents, the turnkey in product or build your own for the last year, but the line between these is really beginning to blur. The in-product agents have APIs, and those have associated MCP tools. That means the agent you build on your own can get results or even kick off new investigations. In the other direction, you can invoke your DIY agents from SOAR playbooks, and they can write the results to SOAR casewall along with other case details. Let's next look at DIY agents deployed to Gemini Enterprise and using MCP tools and other Vertex AI components to do work in the Security Operations Center. This is the Gemini Enterprise Agent Gallery for a project in my platform, in my organization. The deep research, idea generation, and the Notebook LM agents are all made by Google, and the agent on the bottom, the MCP security agent, is a custom ADK agent. The Vertex AI ecosystem makes this custom agent enterprise ready, and thus the name, Gemini Enterprise. It provides governance, guardrails, authentication, authorization, observability, traceability, and much more. Here at Next, there are many sessions on Gemini Enterprise, so I'm going to spend my time speaking to what makes this a security agent. First, it's configured to use MCP servers for the SecOps SIEM and SOAR. It has the MCP for Google Threat Intelligence, Security Command Center, and beyond the tools for my environment, we need to arm the agent with context that is specific to my enterprise, and for that, we use these other features in the Vertex AI ecosystem. This is the architecture diagram for that MCP security agent. In the Vertex AI box on the right, at the top, we have a RAG knowledge base. By grounding the foundation model in the enterprise-specific data, we bridge the gap between general AI capabilities and our organization's unique operational context. For the Security Operations Center, this knowledge is our incident response plans, our standard operating procedures, templates, and sample investigation reports, and other context. As part of this reference implementation, I've shared a starter pack collection of those in this ADK runbooks GitHub repo. This repo is shown in the inset box, and behind that is the GitHub static site that is generated from these plain text markdown files. And I'm going to show several resources like this, so I want to give you one place to find them all. You can find all of this content in my blogs on the Google Cloud Security community, and the short code here links directly to my profile. So from here, let's go back to that reference architecture and see the next Vertex AI component. Below the RAG knowledge is the Vertex AI memory bank. Many materials introduce agent memory and describe tailoring the experience to a user across sessions. But in the Security Operations Center, we want memories across both sessions and users. Analysts need access to one another's learnings. This reference implementation uses custom memory topics like analyst notes, investigation patterns, and tool execution quirks. Similar to the AI runbooks in the RAG knowledge base, the memories are continuously improving our understanding of the nuance of our organization and allowing us to tailor operations. The last item in the Vertex AI box is the model garden. The two models shown are the agents used by the agents in the yellow box. The SOC manager requires more capability and thus uses the Gemini Pro model, where the sub-agents that it invokes are largely instruction following and can use the Flash model. Those sub-agents are configured to use the MCP tools shown in the blue box below. This pattern, using a powerful root agent and delegating to sub-agents, is known as the orchestrator or the coordinator pattern. And it works well for security operations where we have known personas for sub-agents to assume, like the cyber threat intelligence and tier 1 analysts. Using specialist personas helps decompose complex tasks and execute more sophisticated workflows. This reference implementation is using 3 SOC personas, but you'll find several more in that ADK runbooks GitHub repo. So let's see these agents in action in a toilsome scenario that is familiar to many security analysts. A malware campaign is in the news cycle, and you are asked, are we affected? So your prompt to Gemini Enterprise is, my CISO just read the report, unwrapping Earthsniff's gifts from the DFIR report. Ask the CTI subagent to research that report in Google Threat Intelligence. The subagent uses tools in the MCP server for GTI to search for that report, and you can see in the response the GTI report ID has been found. Using that report ID, you could then visit GTI and read the report and download the IOCs, but our goal is for the agent to eliminate the need for that swivel chair analysis. The root agent digests the report and summarizes key findings. The table shows the tactics, techniques, and procedures used by the threat actors in this campaign. For the initial access through persistence mechanism, lateral movement, and exfiltration, and that's followed by the indicators of compromise known to be associated with this campaign. With those TTPs and IOCs now in context, we prompt to kick off a threat hunt. There are high confidence findings for both. Lastly, the AI runbook for threat hunts specifies that the template for a report and that report should both be saved as an ADK artifact. I've hovered over the link in the artifact to show that it is a versioned file in Google Cloud Storage and that it's associated with this session. We also save the AI runbooks used in this analysis to that same session bucket. Another directive in the runbook is to produce a sequence diagram for the tools that are used. And this is an example of that kind of sequence diagram. The 5 boxes show the analyst on the far left, then the MCP client, and then the 3 MCP servers that are called for this particular session. They're the SecOps SOAR, SIM, and GTI. The arrows between the boxes are showing individual tool calls on those servers, and they're annotated with the tool name and parameters for the tool call. Some of the sequences are loops over arrays of items like IOCs. These sequence diagrams are useful in a session's final report to capture the tools that were actually used, but they're also useful as inputs for sessions, for planning purposes, for future work. So sequence diagrams are included in both final reports and also in the ADK runbooks for planning. They're essentially cognitive tools for the analyst as this rendered image, and cognitive tools for the large language model in their text form. Mermaid and Markdown are our interlanguage. This next sequence diagram includes calls to the 3 servers and also calls to 3 smaller runbooks that are namespaced as common steps. Those 3 are check duplicate cases, enrich IOC, and triage summary and recommendations. The ADK runbooks attempt to decompose complex work into smaller pieces that can then be recomposed. These composable runbooks predated the advent of agent skills, but that is essentially what they are, and we've started converting some of them over in the ADK runbooks repo. The coordinator pattern for the custom ADK agents that are running in Gemini Enterprise and leveraging the Vertex AI ecosystem to continuously improve is an end state. I want to speak next about the important stepping stones to reach that end state. This visualization shows the managed solutions shifted to the right and the development environments for creating and testing those solutions shifted to the left. On the y-axis, the interaction layer is at the top and the plumbing is at the lower levels. To get to the end goal in the top right, Gemini Enterprise, you need to start building from the bottom and work your way up. That bottom left is the Chronicle REST API. The source of truth for the Chronicle API is this reference page in Google Cloud Docs. I spend most of my time in the abstractions, like the software development kit, and I'll show you that next. But sometimes you need to go to the source. A direct curl request to the API is sometimes the known working state that you need to eliminate other sources of error. Here we see the GitHub repo for that SDK and the code snippets for one of the most simple tools. You can see in the lower right that this particular function is just a thin wrapper around the Chronicle REST API, and so the repo was initially named SecOps Wrapper. It's grown in scope since then, and the self-hosted version of MCPs for SecOps use this SDK. In fact, MCP tool definitions are themselves just a thin wrapper on this SDK, which I can also show. This MCP tool lists security rules, is shown here, and there are 3 things to note. The first is that the Python decorator, the very first line, line 26, is server.tool, and that's from fastMCP. And this does all of the heavy lifting to turn a Python function into an MCP tool. What's left for us as the author of the tool is to write the type hints for the parameters, like project ID is a string and page size is an integer, and the doc string for the function. The doc string is critical for the LLM to know when to use the tool. Engineering this context is an art and a science. Before rolling these up into an agent, it's faster and easier to test your MCP tools in an IDE like anti-gravity, or as shown here, Gemini CLI. The remote MCP server for Gemini CLI here is configured with an extension. And we just published this Gemini CLI extension to the gallery. The purple badge on the right at the top shows that it configures MCP, but there are also badges for skills and for commands. And here you can see the triage, the SecOps triage agent skill is being activated, and that's also activating a slash command. There are also slash commands for all of the skills. This is one of the ways that the AI and the ADK runbooks are resurfacing, and my colleague Ming Lu has a great blog on the philosophy and the mechanics behind that conversion to skills. So I want to wrap up by sharing some learning resources that I found helpful in my own journey along the chutes and ladders from the API up to the Gemini Enterprise. First, the ADK documentation has great information on the multi-agent architectures, like the orchestrator pattern that we saw earlier. Next, the Google Developer Relations team produces excellent content. Now, I'm focused on building agents for the security operations, but I recommend starting with these videos, tutorials, and collabs produced by this team before switching to the security-specific tutorials. So the stepping stones to get a custom agent starts with the API, proceeds to using that API in MCP and local dev and testing before deployment. You need to get familiar with the tools before wrapping them in an agent, and once wrapped, you need to test the agent locally with ADK Run, ADK Web, before you deploy. That's the place for fast iteration, and it should be done before deploying to the managed services. When you are ready for that deployment, I've created and shared on GitHub some convenience utilities that helped me with this work. These are Python subcommands. It's Python subcommand interface for all of the steps. And there's also a makefile wrapper that as an alternative interface, and it rolls up some of those Python subcommands. And my goal for this work was to separate the configurable bits into a .env file, and that acts as the sole input into these scripts, and it is also a permanent record of what was deployed. I've also shared a Google Colab for a simplified agent that is deployed to Gemini Enterprise, and the work there was to isolate and exercise the OAuth workflow for the managed remote MCP for SecOps, and that bit was tricky, so I wanted to test that in isolation. So this collab has everything needed to do that. So I'm going to leave you here with this infographic and invite Hakeem up to the stage and to tell his journey for building out the agentic SOC at Salesforce.
All right. Thanks for joining us this afternoon. get here. So I'm going to start off with a demo and walk you through it. I'm Hakeem Oseni. I'm the Director of SecOps at Salesforce. I manage our Google SecOps, Google Threat Intel, amongst some other things. So I'm going to talk about our journey to getting to the agentic SOC, and I'm going to play you the scenario. So this demo walks you through an end-to-end flow responding to a critical security advisory report. Imagine it's 4 a.m. Human analysts are not available to perform an impact assessment, but our agents are on standby 24/7. Initiating the hunt, the security leader asks Kestrel, an agent for security orchestration agent, to assess the impact of a security advisory and determine the company's exposure. The leader simply provides the report ID, and the agent figures out the rest. Kestrel initiates a hunt record and passes the baton over to our augmentation agents built using Google's ADK framework. The data collection and the human in the loop. Multiple agents collaborate on this task. First, the normalizer agent acts as the data collector, automatically extracting IOCs and threat context from the advisory report. Once extracted, it asks the security leader to execute a hunt plan, detailing the target data sources and log types. This highlights the human in the loop capability. The security leader can either ask for modifications or approve the execution plan. In this case, we approve and the augmentation agents take over. Analysts can also ask Kestrel for real-time status updates at any point during this process. Next, we get to the agentic workflow. A comprehensive hunt plan is built based on the previously extracted IOCs and threat context. The hunt planning agent, it's the hunt planning agent, there's 4 agents here. The second is an investigation agent that executes the hunt by querying the scene and the relevant data sources. Third, the findings reviewer agent analyzes the pulled logs, the enrichments from Google Threat Intel, and the hunt execution. Fourth, the concluder agent finalizes the impact assessment and provides concrete recommendations. Let's talk about the conclusions and the recommendations. At this point in the execution, the agentic mesh has concluded that the threat is actively present in our environment. It immediately asks for approval to engage the threat detection agent and the remediation agent and the incident commander. Well, right. The value proposition here is, once we approve the request, the agents take full control, a detection rule is then deployed to production, the IOCs are blocked, and the compromised host is contained. The human approves the actions directly via Slack. They never have to switch context or interact with the underlying services performing the detection or the containment or the paging. The human never has to leave Slack. All right, I'm going to click over. I thank my agent, and I go back to what I was doing first. Have a good day. All right, so how did we get here? I'm going to tell you about our journey over the past year. Thank you to Google. We were one of the very early adopters of their MCP server. They've been a really great partner. We wanted to ground ourselves in some reality, and we call these the primitives, right? The 8 primitives are table stakes in a modern agentic solution, especially a SOC where sensitive security workflows are executed agentically. 1, reasoning and planning. We need to break down the objectives and plan steps. For example, the hunt planning agent. 2, tool orchestration. Let's discover and execute capabilities, including agent-to-agent communications, Agentforce to Google. Let's get that state management locked. Remember across multiple sessions where we are in our plan or whatever execution steps we're doing. 4, knowledge and context. Each agent has a persona, and they need to stay within the bounds of that persona or that job function. 5, error recovery. We want our agents to learn from their mistakes. We also want them to pick up wherever that mistake was made. 6, keep the human in the loop. We talked about that. 7, guardrails, max iterations, completion signals, and boundaries, right? What do you not want your agents to do? And last, observability, logging, tracking, and state files. All right, here is our agentic SOC architecture. And rather than building SOC architecture from scratch, our strategy focused on extending our existing investments. We're a large company, we do a lot of M&As, we have a lot of tools. Most organizations have already matured their SIM and SOAR and systems of record. We leveraged the foundation by deploying Google ADK-based agents directly onto our existing SOAR platform. First, on the right, you see the interaction layer. Analysts engage with digital teammates via Slack, which routes workloads to the Google ADK runtime. On the left, we've modularized the agent architecture. We aren't starting over with integrations. We're using a thin wrapper on our agents to execute existing commands already live in our environment. I'm going to walk you through some steps here. So we have Slack, number 1. That's in our digital teammates and our people who work in our SOC. 2, we have the executor and the agent cards. That's the runtime that executes configurations and the agent personas, definitions. 3, the agent executor, which is a Google ADK agent. 4, state and goal files, manage sessions, persistence, and memory, scratchpads, across multiple interactions. 5, the LLM gateway is a centralized choke point for all foundation model traffic to ensure security, cost control, and observability. 6, Capability Executor is the second Google ADK agent, a thin wrapper allowing agents to trigger existing SOAR integration commands going beyond your standard MCP. 7, the Security Action Library, a pre-built library for specific tasks like SIM searches, metadata queries, and internal application lookups. 8, our system of record is our Salesforce org. That's our truth layer for persistent data storage and audit trails. It's a bit detailed. To build a truly agentic SOC, we first map the entire spectrum of security operations, from left to right, log onboarding, to threat intel, threat detection, alert triage, and response retrospectives. We're going to walk you through a couple of thought processes that we had. First, we did a granular audit so that every SOC function is broken down into specific tasks or workloads to assess suitability for automation. After we did that, we looked at this with an agentic filter, right? We identified specific workloads that make sense for an agent or agent capabilities that we currently possess. Tasks that are repetitive, data heavy, or require rapid cross-tool coordination. We then did an AI-ready tagging. Only workloads tags as AI workloads are transitioned to the agentic layer to ensure reliability and focus. Then we had to deliver this to our teammates and our SOC analysts. We do everything through Slack native, and we use, the user has a digital teammate, right? So we think about these agents as, the next person you train, the next person you bring on board. And in this natural workspace, we trigger complex backend workloads through simple conversational interfaces, as you saw in the demo. We always try to keep a human in the loop, so the analyst chooses which workloads to invoke at whatever stage they are. The result is that every functional unit within our SOC has a digital teammate accessible through Slack, and these teammates to offload work to. All right, so what worked? What didn't work? And what potholes not to fall into, because this took a year to do. Deterministic orchestration over autonomous agent chains. Number 2, per workload agents over big monolithic agents. Think microservices. Layered human in the loop over full autonomy. agent reasoning loops over one-time validation, innovation on existing infrastructure over building things from scratch, and earn trust using a single workflow over agentify everything with subpar outcomes. Remember the core 8 primitives that we started off with. And lastly, I'm going to suggest for your SOC, you build an AI constitution. So you codify your primitives and what actually works into a constitution. Not every tool, not every agent, not everything's going to work for you depending on your own work environment. Use this governing document for your agents and your humans as you reinvent your agentic SOC. Let's go through these 6 things. Number 1, primitives for security operations. Number 2, governance and oversight structures. 3, the shared responsibility framework. All right, we're all in this together. It doesn't matter what team you're on. 4, technology exploration and integration management. There are new tools or new features coming out all the time. How are you going to digest them and figure out if you can plug them in to your Lego set, and it's going to make you operate and reduce your MTTX. Agentic asset lifecycle management. What do you need today? What don't you need today? What do you need to peel off? And number 6, evangelize and enablement. Right? I'm going to conclude by saying AI agents are a force multiplier and can extend the reach of your teams by freeing them up to focus on high impact, high stakes work. Thank you.